Hello, good morning, viewers, dear student friends. Uh, Today we are going to see about uh, phase rule, the introductory part, the different terms involved in the phase rule, the significance and the importance of the phase rule, and applications. What actually the statement says? The phase rule is an important generalization dealing with the behavior of it, the whole heterogeneous system. In general, it may be said that with the application of phase rule, it is possible to predict qualitatively by means of a diagram. That is what we are going to call as phase diagram in a heterogeneous system, the effect of changing pressure, temperature, and concentration on a heterogeneous system in equilibrium. This relationship was introduced by or discovered by the great American scientist Willard Gibbs in the year 1874, and hence it is also called Gibbs phase rule. And the phase rule is given by in the form of a mathematical expression f is equal to c minus p plus 2, where the terms f is the number of degrees of freedom, c is the number of components, and p is the number of phases of the system. Before entering into actual part of the study, what we are going to say is we are going to have a outline or a good knowledge in the various terms involved in it, that is phase, component, and degrees of freedom. So what is meant by a phase? Phase can be defined like this, that is phase is a physically distinct and mechanically separable portion. Phase is a physically distinct and mechanically separable portion of a heterogeneous system, which can be separated by boundary surfaces. So phase we can very well define like this: it must be physically distinct and we can easily mechanically separate the every portion of a system which contains one phase or more than one phase in a heterogeneous system. For example, a system containing only liquid water is one phase, or we call it as one phase system, where in the equation F is equal to C minus P plus 2, the P stands for phase, that is P is equal to 1, where it is only H2O. A system containing liquid water and water vapor, for example, it is a gas, is a two phase, or I call it as a two phase system. P is equal to 2 for this system. For example, H2O in the liquid form is in equilibrium with H2O in gaseous form. It contains two phases. Similarly, a system containing liquid water, water vapor, and a solid ice is a three phase system. H2O in the form of solid in equilibrium with H2O in liquid, in equilibrium with H2O in gaseous form. For example, if at all I consider only one phase, then I call it as a homogeneous system, whereas when we have more than one phase,